All right, ME 4260, 5260 class. This may be the last video, I'm not sure, but I'm going to do this one on system analysis here. And I kind of skipped over this in the slides previously, and I want to go into it in some more depth and detail. So this is an example of kind of an interesting system that I looked at a number of years ago. This was, I think, Decatur, Illinois. And this is a nice diagram that was in a report that I had that kind of shows what was going on, or at least the layout of the system. So I'll talk through this a little bit here. So they had four air compressors. Three of them, these top three, were in the main compressor room. And this 200 horsepower Gardner Denver was out on the other side of the plant. And they did a project to make this more efficient, and this is the resulting system from the project. But they didn't, it was just too much trouble to move the 200 horsepower Gardner Denver, so they left it on the other side of the plant, which is kind of an interesting setup here. They do have a master controller that decides which compressors will run and apportions load to the compressors. And so we see these two, well, we have 150 horsepower Solair. These are all lube injected rotary screw compressors. And so the 150 has a dedicated desiccant dryer. You see the twin towers. And we got filters, moisture separators, and all that stuff appropriately. And then the 100 horsepower Solair and the 100 horsepower Quincy are set up to work with this refrigerated dryer. So this was a new dryer that was added as a result of this project. So that's kind of interesting there. We've got desiccant dried air and refrigerated dried air mixing together. So, you know, we would expect a -40 dew point on this air and probably a 37, 38 degree dew point here. So the air coming down through here would be someplace probably around zero, you know, whatever the kind of mixed mean temperature was. We've got, what's that, 2,560 gallons of storage right here. And then these feed into a demand expander or a pressure flow controller. And so this is that quick acting valve that's going to set the downstream pressure plus or minus 1 PSI when it's in charge and is able to do that. But the 200 horsepower compressor just feeds directly into the loop. And we also notice that the plant is drawn up as a loop type piping system, which is the preferred way to do it so that you can feed air to support pressure from multiple directions. Like if you had a big use over here, you can feed air from this direction and this direction. So it helps minimize the pressure fluctuations in the system by having a loop. So that's a best practice. And then we see the 200 horsepower Gardner Denver down here that ties directly into the loop. So it's not upstream of the demand expander. So that's a little bit of a unique layout, I would say. Okay, and just some notes on the system here. Compressors upstream of the demand expander. So that would be these three, the 150 Solair, the 100 Solair, and the 100 Quincy, operate between 87 and 93 PSIG. So they are load unload machines that we'll see. And, you know, that's a 6 PSI band. So that's a fairly tight band. You know, kind of the overall standard is usually 10, someplace 8 to 10, maybe 12. The demand expander is set to maintain 85 PSIG at its discharge. So that would be right here. This device is trying to maintain 85 here, which hopefully will set the pressure in the loop. The 200 horsepower Gardner Denver is connected to the system downstream of the demand expander. I said that. And the 200 horsepower Gardner Denver operates on a 96 to 103 pressure band with slider valve control. Okay. And the master controller can start, stop, and decide which compressors to operate. Okay, let's see. So I'm going to go from here to the live data. So this is, make sure I'm on the right system. Yeah, I am. And so, no, that's not the right system. Let's see, this is, here we go. I've got several different systems open here. So let's just play around with this. Let's back out a little bit. So I'm working with this data live, and we can look in different time windows and excuse me, my goodness. We can expand it and contract it and do all kinds of things. So I'm going to show you the whole data file. Okay, so this is the whole data file right here. Let me see if I can expand it one click there. There we go. So this is a number of days. Let's see, we started this on a Sunday. And so this is Sunday, and then this turns into Monday, and this turns into Tuesday. And we were there basically 3 days. And so you see things start up as we were moving around the plant, putting the data loggers on. So we didn't get them all put on. See, this is pressure in blue. So amps on the compressors are on this scale on the left, and the pressure for the system pressure is in blue on the right. And we'll take a look at all of this. So that's the entire data file. Some things to note just in general. Things were really topsy-turvy on Sunday. This is just a mess. So I'm going to come over here and start over on this side and start talking about it. This is the end of Sunday and the start of Monday. And then, let's see. All right. Yeah, so this is Sunday. Let's see here. You can use this little tool and see back over here. This is 6/12 of 16. Yeah, I'm still Sunday. There we go. And that changes to Monday right there. And then, yeah, I guess we took them off Monday. I was thinking we got into Tuesday, but I guess we took them off Monday. Okay, so we only have like 2 days of data, which is not great in and of itself. But anyway, that's what we got. Okay, so let me expand this out over here and show you. We got things operating pretty good over here. And let's see, expand that a little bit, and we'll expand that a little bit. I know I can move this stuff around. So I'll put the pressure up here at the top. And then the amps you see are moving down here. So that's 0. Okay. So this is how they really intend to run the system unless these 2 compressors can't keep up. So this is the 200 horsepower Gardner Denver. And you see if I hit this little plus, and then if you look over here, as I drag this marker back and forth, you'll see the amps. Well, you see all of the data as we move through time. But if you look at the top over here, right in here, this is the amp. So where that's sitting right there, that black line is 219 or 218.9 amps. And I can drag it back and forth and you kind of see what's going on. So you see, this is full load on the Gardner Denver. It's making all of the air it can. And then the Quincy, the 100-horse Quincy is running load, unload, and it's loading and unloading. So it is the trim compressor. And as let's get down in here. So you see, if you look at the red one, that's the second one right there, 21, 21, etc. As I move that, it goes up 122 and get up there about 120, almost 125, and the machine unloads. And then it goes down to 47, and so on and so forth. So up and down, up and down. And so you can see roughly, looks like it's loaded, it's running about 50%. You know, this load cycle, see, here's one. If I look from here to here, this thing ran more than it was off. But when I get over into here, looks like the load and unload times are about the same, maybe a little more load. So maybe it's, 55, 60%. I mean, I can do some mathematics on that to determine, but we certainly don't have the trim machine fully loaded. Now you see, we got a period right here where this thing, let's scoot that over and see, say it ran longer, so the demand went up a little bit, but still we were okay. And this is the pressure you can see up here. And this is the action of that demand expander. This is that fast acting valve opening and shutting to maintain, looks right about 85 PSI. I can use this tool and I can drag it across here. And then for this period of time, that's an hour and 18 minutes. And then I can come over here. And if I click on these things, it'll show me some statistics. So for pressure during that period, there's almost 4,700 samples. That's 1 second data. Max is 86.84, min 84.63, average 85.7. So see, that is really very, very well controlled pressure out in the plant. Okay. If we look at the 200 horsepower Gardner Denver, I mean, its max is 222, its min is 216, and its average is 218. So that the only difference there is it's responding to the small differences in pressure that it sees as it pushes air out into the system. So it's really flat. And you see it's flat loaded at its full load amps. So this is pretty good. I mean, this is what they intend. This is what they wanted to do. Okay, as far as being able to operate the plant. So it's hard to criticize this. We could look at how long this Quincy is staying unloaded. We can blow this up. Let's look at some of these cycles here. Let's see, and then I can drag this, so like we can look at this one. Okay, so if I go back to the compass tool, this thing unloads about right here. Yoo-hoo. Come on. Sometimes the computer can't keep up. That's not quite on the point, but it's pretty close. So that's about 2 minutes and 15 seconds. Wow, heavens, that's our rule of thumb. That's pretty good. If we can keep it unloaded 2 minutes, we've done pretty well. And you see how the current comes down and falls. That's while that sump is blowing off. And then once the pressure gets down to its minimum level on the oil air separator sump, then we flatline the current. So the other thing we could do is we could get some kind of an idea here. Let me see if I can get a little better on that point. Oh, sometimes this thing is temperamental. There we go. So, well, it looks like this one's falling pretty quick. Looks like this is going down. That's about 16 seconds. So this sump is blowing down quicker than most. So, sometimes you see them this fast. Most of them, like I said, the average is about 40 seconds. So this one's getting down pretty quick. If it's not causing foaming in the compressor lubricant, carrying it out in the system, then we're probably okay. So this one seemed to be working all right as far as that's concerned. Okay, so let me see. Let me now put this back together a little bit. Oh, and the pressure stops because the battery died. My pressure loggers require a rechargeable battery, and it wasn't the best battery in the world. We charged it, but it gave up the ghost right about here. So that's why that stops. Okay, so let's go back a little bit here and now see, well, let's just go back a little bit more. Let's go back, and let's go back to early Sunday morning here. I'll show you some interesting things that happened. Okay, so this is Monday morning, 5:20 a.m., 5:40 a.m., 6 a.m. People start coming to work, start firing up the compressed air demand. And so this is how they wanted to operate on Sunday. Okay, so like I said, there was a bunch of upset, but we finally got it worked out because, you know, if you look in through here, the 200 horsepower is off. This 100 horsepower Quincy is the only compressor running. The pressure's 85 or so, which is fine. And the other two compressors are basically off. So, I mean, wow, that's pretty good. And, you know, another comment here is if we determine the amount of load on the compressor, this could be the leak load in the plant. If there's no legitimate air use going on between, you know, 5:20 and 6 a.m. in the morning, then we could determine, because the capacity of this compressor, 100 horse, so it's probably 450, maybe 500 CFM. I mean, you can look that up, and then you can figure out what percent of the time it's loaded. And you can see in here, these cycles are very, very regular. And so I suspect that's the plant leak load, or any open blowing that they've got going on that potentially shouldn't. I mean, there may be some legitimate air use, but I tend to doubt it pretty well. So, you know, just an eyeball estimate, I'd say that's at least 75%. So, you know, 75%, and, you know, we can calculate it times 0.75. So that's about 300, and that's someplace around 337, 340 CFM. That well may be the leak load in the plant. So that's of interest. We see the demand expander is doing what it does. So that looks pretty good. So then what happens? Okay, so we start firing up process. Okay, and we've only got one compressor on. Say, so the pressure falls. We lose control of the pressure. It goes down to what, 78, 70. I mean, we can tell. So pressure's falling, pressure 70, down there, 77.6, something like that, before we start an additional compressor. So then see, at that point, we jump in. Let's see what's happening here. So the 200 hadn't started. We got the 100 horsepower Quincy running wide open. Pressure's low. We got the 100 horse Solaire has kicked in, and it's running fully loaded, looks like. So we got two right in this region. You can see this kind of purple one is now running. Well, and so with those two running, the pressure really comes up quick. Pressure kind of spikes on us even a little bit. So we got a little bit of instability. And then the Solaire unloads. So we can see right there, I'll get the pointer. So the Solaire unloads, and then the Quincy unloads, and then they both load, and then the Solaire is running load, unload like it's the trim machine, and the 100 horsepower Quincy is base loaded. We kind of get control of pressure again, but then all of a sudden we start the 150 horse Solaire right here, that's this spike, that's its startup current. And see, it runs up here, it runs a little while. So it's running loaded. The red one, the 100 horsepower Quincy is running loaded, and the 100 horsepower Solaire is running unloaded. So this is getting a little bit out, not so good. Well, so we go on a little while. And so then the red one, the 100 horsepower Quincy, has become the base load machine, and the 150 is trimming the system. And the 100 horsepower Solaire runs unloaded for its timeout period. It times out, and the master controller shuts it down for a little while. So we can see basically from when it unloads about right there. And so looks like it's got about a 10-minute timeout period. So that's 9 minutes, 53 seconds before it shuts down. And let's see, whoops. There we go. Well, it's not wanting to slide. What's wrong? There we go. There's quite a bit of data here, so it kind of bogs the computer down a little bit. And so we kind of keep this little kabuki dance going with the red one base loaded and the other two kind of coming on and going off. So we can see here, if we look at this, we're rocking along here. We've got two of them, the 150 and the 100 running. And then all of a sudden now right here, we've got three of them running. We got right in here, we've got, well, the 200 horse is still off. We've got the 100 horse Quincy loaded. We got the 100 horse Solaire loaded. We got the 150 horsepower Solaire loaded. Okay. And so they continue to jump around a little bit. Again, later on, 100 horse Solaire shuts down again. It's not down very long. Let's see how long it shut down. Here, it shut down for 22 minutes. And then here, it shut down for about 5 minutes before it restarted again. So this is really not programmed terribly well. This isn't too good. So what happened is, I kind of glossed over here. What they want to do is they want to run the 200 and this 100 horse Quincy. They tried to start, the 200 tries to start in here briefly, and it had an electrical problem. It had some kind of a contactor, so it wasn't major, but it wouldn't let the machine run. So it tried to start it here and it couldn't run. And then you see the black spikes up here for just almost instantaneously. And so it couldn't run. So that kind of threw it into a little bit of a tizzy trying to work out, what mix of compressors it was going to run when it couldn't run the 200 horsepower. So we keep fiddling around with this stuff going on, and say then they fix during the day here. In a few minutes, you're going to see the 200 got fixed. Here we go. They had whatever little relay they needed. They could replace it themselves. So the electricians fixed it. Now you see the 200 comes on and it goes base load immediately. And so then the 100 horse Solaire is off and just stays off. And then shortly thereafter, the 150 horsepower Solaire goes unloaded, and then it times out. And I suspect that's probably 10 minutes, its timeout period from roughly there. Let's see what that looks like. Yeah, that's roughly 10 minutes. Okay, so it timed out. And then we were, rocking like we want to, and life was good. Okay, so that went on. Whoops, I'm pulling my tags along here. Let's look at Sunday, where this was really early part of Sunday when we first got this stuff rolling here. We'll come on over here. And there's some interesting stuff goes on here. Let's see, I'm gonna shrink down this pressure axis a little bit. Yeah. let me shrink it down. Then let me move it up, as you'll see here in a minute why I'm doing that. Okay, back to the hand. Okay, now, this is kind of interesting. So this is Sunday morning. Well, or is this Monday? This may be Monday. Let me see. This is Monday, but this is Monday morning, but this is not so early. So it's interesting that the system kind of got control of itself. Let's see. It kind of shifted mode right in here about 240, someplace in there. Because see, we had this weird operating pattern over here, which is all screwed up. And then all of a sudden, it got control of itself. So I don't really understand, but it's all in the programming of that master controller. But what's interesting is when the 200, see, this is Sunday, there's not much air demand. And so here we're operating the 200 and it's just way too much. I mean, that's a 200, that's nominally 1,000, 900 to 1,000 CFM, and our load is maybe 300. The leak load, maybe between 3 and 350. And so watch what happens. And this is slider valve control, which is kind of interesting. And so our pressure, look, our pressure is up here over 100. And that's because this thing doesn't go through the demand expander. So if we look over here at the diagram, this 200 hooks directly into the loop. And so it's running kind of on its own controls, it looks like. And it's set higher than the loop is. So when this thing runs and it has more capacity than we need for the system, then it runs on its slider valve and then it finally unloads and it drives the system pressure way up. So that's what we're seeing here. See, all of a sudden, instead of having pressure down here at there's 80, 85, we would be down here if the demand expander was controlling it, but it's not. This is being controlled by the individual pressure controls on the 200. And this is that slider valve moving back and forth. And finally, it's just too much. And then the compressor finally unloads. It's like an auto dual mode. And then it's down here, it's producing no air. And then the pressure falls back to the unload point. And when it gets down to here, we can see what that is. Let's say, so when the pressure finally gets down to about, what is that? About 90, about 96, this guy loads again and it runs. And all of a sudden, when it gets up to someplace in here, what's that pressure? That's 100. Looks like it's, in general, it's maintaining someplace around 102. And then eventually it gets just high enough and it unloads the machine. So that's kind of interesting. So this is a time when this 200 horsepower should not be running. We should be running this 100 horsepower Quincy by itself. So this goes on for a while. Now we're going back in time. Oh, well, look. So now here's a period where we were running the 200, which was too much. It unloads, and all of a sudden it starts the 100 horse Quincy, and then they both run together. And then the Quincy unloads, and the 200 horsepower is loading, it is bouncing back and forth on the slider valve, and then eventually it unloads. So we sure don't need both of these things running. Oh, and it gets even better than this when we go back. So it did that stuff for a while. And this now we're getting earlier. We're going back in time. So Let's just keep going back here. I guess I could shrink it, but there's some more up. There's the red one starting again for no reason. Well, I mean, the red one should be running and the black one shouldn't be running. Well, I'm going to have to shrink this and then let me shrink it so I can find what I want here. So it's that same pattern, but it gets MPN. Well, shoot. Hang with me. Okay, this is pretty good. So, okay. So now look at the pressure trace here. Is this so this shows, so for some reason, I guess it's the master controller. I don't know. But so it allows this thing to completely unload. And so this is it sump blowing down and it's just coasting down and it's not really producing any air. And so then the loop pressure is maintained by the demand expander with the 100 horsepower Quincy running, and see the pressure falls back down to 85, between 85 and 86. So you see the demand expander is under control and the 200 horsepower is not. And then all of a sudden, for Lord knows whatever reason, the 200 fires back up again. And so then it takes charge because it's dumping air directly in the loop. And so it's running on its control. So it goes back up here and is doing, I don't know, what is it, 102 to, we can see, you know, up in here, you know, we're doing 102 and then eventually it unloads at about 98, 96, whatever. So that's pretty strange. But then we get to this period and now let's see, at some point the green one kicks in over here. Let's see. So this thing, I was going to show you, I can't find the green one kicking in. Well, this is just so strange. So when we just run the red one, we're on the demand expander. When we run the 200, we're up here on its controls. And it's jumping all over the place. Well, I think that's enough. I don't know. At some point in here, we got the green one going, but I'm not finding it right now. But at any rate, this is the kind of information. I mean, when you really do an analysis on a system, you have to log this stuff, and like 1 second intervals is pretty good. There's a few things you sometimes want a little faster logging. 1 second's the fastest that I have equipment that will do. But in general, 1 second data is pretty good. And, you know, if you let this run a week with a number of compressors and pressures and all that sort of thing, you generate some pretty large data files. So this particular software is pretty good for analyzing these things. You can dump to an Excel file. You can do this averaging, and it's got some other statistical tools that help out. Okay, so I think that's good. I don't want to just drag this out too much, but so the exam will be just over compressed air, and it will be at the stated exam period. I'll send out an email. I'll put the time in the email when I send this link. I haven't looked it up yet. I think I put it on the syllabus, but you can look. So we were, what, noon to 1:20 on Tuesday, Thursday. So you can look that up on the tech exam schedule. I think it's the Tuesday of exam week, but I'm not sure. So check into it. I'll open it on iLearn, and you'll have that period, exam period, to work it. So I've enjoyed the semester. If I can help any of you guys in any way, need a reference or anything, let me know. And I wish you guys the best. So hope you have enjoyed the course, and I guess I'll be posting final grades as soon as all the dust settles here. So hope you guys have a great rest of the week. Talk to you soon.